So examples 8, 9, and 10 in this document are different from the ones in the textbook. Normally I just go by the textbook examples and use those. But when I was making the document, for some reason, when I went to the e-text, there was like 3 pages that wouldn't show up. So I pulled examples from the homework, which I think will actually benefit you more to see. But I've included the ones from the textbook at the end of this document. So there's videos to go with those too. But if you were following along in the textbook and you're like, hey, this example's not example 9, it's because I pulled it from the homework to try to give you some examples of the homework problems. Okay, so hopefully that makes sense. If it doesn't, the examples are all good, and just watch them and learn, and then it'll help you with the homework. Okay, you can't see too many examples, I say. So this is example 9. Well, it's my example 9, I guess. And you'll notice that there are 2 absolute value symbols. So there's one on the left, and there's one on the right. And in the homework, they had several examples of these kind of problems. So what we're going to do is we're going to make 2 cases. We're going to take the 2x minus 7 and say, well, that could just equal x plus 3. And if you took the absolute value of both of those, yeah, they would be equal to each other. Or the 2x minus 7. So you're going to keep this one the same, equals the opposite of x plus 3. And I usually put the opposite one on the left, so I didn't this time, but that's okay. Don't make them both opposites, because then, that's like you didn't change anything. So keep one of them the same, and it doesn't really matter which one. I keep the one on the left the same, and then on the right, you'll see this is x plus 3, but this is the opposite of x plus 3. Okay, so that's how you set them up. And then we're going to get 2 answers. These are just linear equations to solve. Subtract the x. X minus 7 equals 3. Add the 7. Here I get x equals 10. And on this other one, I have to distribute the minus sign. And then I'm going to have to add x. So I get 3x minus 7 equals negative 3. And then I add 7, and I get 3x equals 4. And then I would divide by 3, and I would get x equals 4/3. So there are 2 solutions, 10 and 4/3. Now, let's go ahead and check them just because we can. We're saying the absolute value of 2x minus 7 equals the absolute value of x plus 3. That was the equation. So here comes the check. And we'll check them both. Why not? So if I put in 10 for x, what do I get? I get 20 minus 7, and over here I get 13. So yeah, that looks right. The absolute value of 13 equals the absolute value of 13. Yeah, that one checks. Now what about that 4/3? So let's do another check. And we're saying the absolute value of 2x minus 7 equals the absolute value of x plus 3, same equation. But this time we're going to put in the 4/3. It'll be a little harder maybe to check it because of the fraction. Whoopsies, that's supposed to be an absolute value. This is kind of interesting to think about these coming out to be the same. Okay, so I have 8/3, just multiplying fractions, minus, I'm going to make this a common denominator, 21/3, right? And then over here on the other side, I'm going to have 4/3 plus, again, getting a common denominator, 9/3. So look at what happens. We get 8 minus 21, which is negative 13/3. But if you take the absolute value, you get 13/3. And on the right-hand side, if I add them together, sure enough, I get the absolute value of 13/3, which is 13/3. So yeah, they check out. So that was kind of interesting. So fun problem.